And now we have a segmentation surrounding only the ball. This could work also in videos. It could work for different objects in the ball. We could display multiple objects in real time, for example, selecting. Hi, welcome to this new video. I'm Sergio. I'm a computer vision consultant and developer. I build computer vision solutions to help companies improve their process efficiency, reliability, and scalability. Today we're going to see some exercise on how to use computer vision to segment an object. Specifically, we will see object segmentation with YOLO version 8. If you're a beginner into this and if you don't know what is object segmentation or object detection, let's now see the difference between the two of them, and later we'll jump right away into the code. Let's go. What is segmentation and what is the difference between object segmentation and object detection? The most common operations in computer vision are mostly three. Object classification, for example, if we take in consideration this picture, object classification, it means classifying what's in this picture so we can get as a result, in this picture there is a rugby ball, there are trees, there is grass, and so on. That's classification. We get just information without knowing exactly the location in the picture. Second, object detection, it means not only detecting what's in the picture but also detecting the position, and we will get a bounding box surrounding the specific object plus the class. So this will be ball, rugby ball. Then we will have the same also for the other objects that our model can detect. So we'll have trees and so on. What is object segmentation? That's the one that we will see today. It means not only having the bounding box, but also the exact segmentation of the object. Plus, of course, we will know what is this. So we'll have rugby ball, we have a bounding box, if we want to have that, plus the segmentation, and of course also we have the class, so we will still know what is this. And of course, object segmentation is the most advanced one of these, and it's mostly useful if you need, for some reason, to detect the shape of the object, if you want to calculate the size of the object, and this kind of operations. Let's now jump right away into the code. I have this code right here. Let me show you. So for the code, I will start coding a file from scratch, and you can follow along. Plus, you need to download the link that I will put down below in the blog post, because there will be the YOLO version 8 model for segmentation in the file there, plus a very simple module that will allow you to do the segmentation very easily, because normally there are things that we need to extract for the segmentation, and I put them into a file that I created that you can download. So we will import that file, and it will make all the process simple for you. Also, you need to install the library Ultralytics. So it depends on what you use to go with Python. So you should install that depending on how you usually install the modules, the Python modules. So it will be pip install Ultralytics, and then you press enter, because we'll be using the YOLO version 8 from Ultralytics. And then pip install OpenCV Python, because we will be using the OpenCV library for this project. Once we have the libraries installed, let's now create a project. First of all, let's load the image. So I'm going to import CV2, and then let's load our image. So we have this rugby.jpg. You can of course load your own images. We have now, when you download the package from the link below, we have YOLO version 8 segmentation. And then images. Inside we have two images. One is basket.jpg and then rugby.jpg. So let's load now rugby.jpg. img equals cv2.im read. We want to read the image from, now we need to put the path of the image. Images / rugby.jpg. Now, to make sure that we are loading the image correctly, what can we do? We can show the image. cv2.im show Title of the window, let's say image, and then what do we want to show? We want to show EMG. cv2.wait key. Now the code, let me show. We run this. It displays the image, but it closes very soon. So we need a wait key event to keep the image on hold. cv2.wait keep 0. So this function is keeping the code still active until we press a key on the keyboard. So this is the image, and we can see now the rugby ball. We can shrink a bit the image if we want, because now it's bigger than the screen. So if we want, we can say emg equals cv2.resize. We want to resize emg. We can define a specific size, for example 500 by 500. We don't want a specific size, we want to keep the proportion, so we'll say none. Instead we want to let's take 70% of the width of the image, 0.7, and fy we take 70%, so that we can see the full image in the screen. Okay, now the image fits the screen. Now we need to proceed with object segmentation. So as I told you, if you do this operation manually from the standard library, there are a lot of things that you need to extract. This is an example to extract the segmentation. A few technical things, I mean not really a lot, few technical things that I hide it into the YOLO segmentation py file, which will do that in the background for us. So we just import the file from YOLO underscore segmentation, import YOLO, import YOLO segmentation. Before you ask, where do you install YOLO segmentation from? Because this is not a module, this is a file that you need to download below. So if you're getting an error, it's because you are not using this file in your folder, YOLO segmentation.py, that is on the link below. So once you import this, to make sure that you are importing that correctly, you run this. If you don't get any errors, it means that you are importing the file correctly. If you get some error, like for example, let me misspell this. So if you get this error, no module name YOLO segmentation, it means the file is not there in the folder with the main.py file. Let's now perform the segmentation with this. For the segmentation, we need just to say first create a segmentation detector. Let's call it like this, segmentation detector, and it will be YOLO segmentation, and we need right here to put the model path. The model path is YOLOv8m, YOLOv8m dash seg.pt. Also this one, it will be included once you download the files. And let's call this YS YOLO segmentation. And now it's very simple. Once we want to get the result from the image, we can say ys.detect. Where do we want to detect the segmentation on EMG? We get 4 outputs from this, and we'll see them one by one. The bounding boxes, B boxes, the segmentation, the classes, and the scores. I'm not sure about the order. Let me just quickly check. Box, classes, segmentation, and scores. So I mixed the order. So we get boxes, bounding boxes, classes, segmentations, and scores. Let's now loop through them, or let's print them first. Let's just print bounding boxes. Let's make this very simple, and let's run this. So once we run this, it's loading. Now it will take longer than just loading an image because it needs to load the object segmentation model YOLOv8 into memory and then perform the segmentation. Once we print, in this case, bounding boxes, we see a bounding box 538, 358, and like we see 4 numbers. What is this? We will see it in a bit, even if you can already guess what this is. Let's take another image. Let's take, for example, this was one basket.jpg. I want to show this image because there is some difference with this image. With this image, basket.jpg, so let's run it on this image also. And we have the output of this image, basket.jpg. And I wanted to show you this because now we see many more numbers. These numbers right here represent each of them a bounding box or of a different object. In this case, we have not only the basketball, but we have like people and probably some other object that the YOLO version model can detect. And that's why we get these more bounding boxes. Let's now go further and let's now also see classes, segmentation, scores, and so on. We start now looping through them for bbox, class ID, seg, score, in, zip. So to each bounding box, we have associated a class ID, a segmentation mask, and a score. So what we are doing, we are looping through all of them together, and then to the first bounding box, we have the class ID, segmentation, score, and so on, so that we get the information of each of them. For bbox, class ID, seg, score, in bounding boxes, classes, segmentation, scores. Let's now print bbox. Let's now print all of them. So we have bbox, comma, class ID, seg, and score. We could also put some comment, bbox, like this, so maybe it's more clear. Then class ID, then seg, and then score. And let's now run this one. We have bounding box 73, 42, 787, 1042, class ID 0. Then we have the segmentation, we have a polygon, and then score 0.95. Then bounding box of the second object, class ID, and so on. Let's go slowly through them. We start now using this information, so let's not print them anymore. And instead, let's now use the bounding box. The bounding box is the surrounding of the object, so it's bounding box. Let's now extract this. So you saw that there were 4 numbers in this, and they are the coordinates of our bounding box. To draw a rectangle, we need top left point, bottom right point. So we have top left, which is x and y that we get from that, and right bottom x2 and y2 equals bounding box. Let's now draw a rectangle from this. C2.rectangle. Where do we want to draw the rectangle? We want to draw it on EMG. Now let's use top left point x and y, right bottom point x2, y2. What color do we want to draw this rectangle? Let's make it red. 0, 0 to 55. 0 of blue from 0 to 255. 0 of green, 255 of red. Thickness of this rectangle, let's say 2 pixels, so that it's well visible. And now let's run this one. Now you see that in this image we have a lot of rectangles surrounding the people and the ball that we don't see. Okay, here we see some part of the ball. I want to go and make now this simpler. So let's focus on our first image, regb.jpg. Regb.jpg. Let's focus on only on the reg ball, and later I will show you also the rest. We focus only on this. Okay, we have this running. So now we have a bounding box surrounding the rugby ball. We are talking about object segmentation. We don't, now we have a bounding box, but we can have the segmentation. So I wanted to show that you also get the bounding box, but that's not the goal of this video. Let's now also show the segmentation. So this bounding box, then we have seg, and it's a polygon with the coordinates. So if we print seg, so if we put seg, we see a lot of numbers. These are coordinates of the surrounding of the ball. So we can use these values to draw the polygon, use the OpenCV function to draw polygons. So cv2.polylines, where do we want to draw a polygon on EMG? Now we need to specify the polygon, so seg, and we need to put this into brackets. That's how the polylines function takes the coordinates, the numpy array into brackets, and then we need to specify the color. Let's make this blue so we can see the difference in comparison with the bounding box. So 255 like this. And I'm forgetting probably something. Yeah, we need to say, is the polygon closed? True or false is true. This means that the function is connecting the last point of the polygon with the first point. Otherwise, it will keep the polygon open. Also for this one, let's say thickness 2. And now I want to make sure that everything is correct and there is no typo or error with this function. Let's run this one. And we have now the segmentation. You can see the blue polygon that we have surrounding the ball. Now, object segmentation will allow you also to understand what class this is, so what object this is. And we have 80 different categories that our YOLO detector can detect. And I have this list right here. So we have, this is the list where the YOLO model has been trained for. We have person, bicycle, car, motorbike, airplane, and so on. And somewhere, of course, we have like the sports ball, which is the one that we are detecting. And so to each of these, we have a different class associated. And we can display also this information. For example, we have the class ID, and we can display the class ID cv2 dot put text, and let's put the text on EMG. Now, what text do we want to display? We want to display the class ID, string of class ID. After this, we need to say the position where the text should be. Let's put this close to the bounding box. So the bounding box, we have the top left point, which is X and Y. So we can put X and Y. We don't want the text to overlap the bounding box, so let's put that a bit above. This means let's take out 10 pixels. 10 pixels from the y-axis, so it goes 10 pixels above the bounding box. And then we can decide the text, the font, cv2.font, hair shape plain. So I'm putting just some random font, like we don't really care now how it looks like, so we care more about the functionality. Size of the text, let's say 2. Color of the text, let's make it red as the bounding box. And the thickness of the text, let's say 2. Now let's run this. I want to make sure that the text class, everything is correct. And if it's so, we should see that on the screen. And right now we have here class 29. Class 29, which is the sport ball, and I can show you that. So if we go to the line 29 of this list, which is the one the Coco model has been trained for, we should have the sport ball. So let's look for it. Line 33. So probably it's either I have the wrong list or there is something wrong with this. Well, apparently it's probably detecting this as a frisbee. I'm not really sure this is similar somehow to a frisbee, but it's more about wrong detection. So we have the perfect segmentation. There is some mistake with the class. So we have line 30, which is index 29 with frisbee. We will see with some other images that the detection will be correct also regarding the class, but we have a very good segmentation. So despite the class YOLO is somehow mistakenly giving us the wrong one, we have a very precise segmentation of the ball. And also this is just a sample that I'm showing you with some specific model, but you need to know that there are some parameters that can be tuned to increase the accuracy, whether it's to improve the performance regarding like to have a more accurate segmentation boundaries, or like performances in terms of speed. So many things can be done with this. So keep now this in mind. It's just an exercise to show you how we can access this information and how we can show the segmentation on the screen. I want now also to go to the other image with what we are showing right now. So regb.jpg, and let's now load basket.jpg. I'm going to shrink this a bit so we can fit it on the screen, 0.5, so 50%. So in this case, you see that we have the ball, which is detected with index 32. So in this case, everything is correct, because in that case, we have the sport ball, not 29 as before. But also we are detecting a lot of classes 0. Classes 0 is person. And if we want, we can choose. So if our project, like in this case, we want to detect only the ball, we can decide, okay, let's display only the ball. And we could use an if statement. So just right here, after we loop through it, we can say if class ID equals 32, then only in that case we want to display the bounding box, display the polygon, and so on. Let's now just display the polygon. Let's make it red and very big, well visible, 4 pixels thick, surrounding the ball. And let's now run this one. And now we have a segmentation surrounding only the ball. This could work also in videos. It could work for different objects in the ball. We could display multiple objects in real time, for example, selecting only the ball plus a chair, and like maybe exclude person from this. So there are many things that we can do with this. And as you can see, with this implementation, the code is very simple and intuitive. I'm going to put all this code, so everything that you see right here, it can be downloaded from below. I recommend, of course, to play around with this and write everything that I wrote today from scratch, because that's the only way you can understand better each step, and that's how you can work more easily later, instead of just downloading the code and running a pre-made code that I've done. I hope this was useful. Let me know what else you would like to see, what projects you would like to build with instant segmentation. And also this needs to be considered only as an exercise, because of course, if you need to implement this into some specific project, there might be many more things to take a look into, like for example, the installation with the graphic card for faster processing, how to tune all the parameters, either for faster processing, for better accuracy, or also how to implement all of this into a project, and so many other things. If you need some support, consultation to develop industrial projects, commercial projects, you can contact me from the link down below, like pysource.com/contact. If you need to learn more about object detection with OpenCV and deep learning, I have a full course on pysource.com. This is all for this video. See you in the next one.